Hello students, on the last video we were discussing about the consistency of the soil, in which we were discussing about the consistency chart. If we made a graph between the volume of the soil and the water content, it will be like this. It will be constant up to a limit, up to certain moisture content, up to certain water content. Then it is increased linearly. As we increase the water content, the volume of the soil increases. So from this consistency chart, we conclude these four states, that is solid state, semi-solid state, plastic states and liquid state. So first of all, let me tell you that what are the four states are. The solid state are those states of the soil of consistency in which if we increase the moisture content, there will be no increase in the volume of the soil sample. Up to that point, from dry condition to a certain moisture content, it will be in solid state. When all the soil solids, when all the voids in the soil solids are fully saturated by the water, then the further increase in the water content will increase in the volume of the water content, or volume of the soil. So up to that point, when the start of the increase of water volume takes place, it is solid state. After that, there is a semi-solid state and plastic state. Semi-solid state is that type of state in which the soil is in, neither it is in plastic state, that is it can be molded into any shape, nor it is in semi-solid state, not in the same solid state. And the plastic state is the state of the consistency of the soil in which you can mold the soil in any shape without crumbling. And the last is the liquid state in which you can have the soil just like a flowing fluid. Means it is in liquid state, it may that is in flowing state, but have some shearing strength against that flow. So between these four states, that is solid state, semi-solid state, plastic state and liquid state, there are three transition points from where these states changes from one state to another state. These are the three limits known as the Atterberg's limit, namely shrinkage limit, plastic limit and liquid limit. Shrinkage limit is the arbitrary limit between the solid state and the semi-solid state, and plastic limit is the limit in which is arbitrary between the semi-solid state and plastic state, and liquid limit is the arbitrary state between the plastic state and the liquid state. So one by one, these are also known as the consistency of soil. This chart is also known as the consistency of soil, and these limits, that is shrinkage, plastic and liquid limits, are known as the Atterberg's limit or limit of consistency. Now this and shrinkage limit can be defined accordingly. First of all, liquid limit. Liquid limit is the water content at which the soil is in flowing state but have some small shearing resistance against that flow. This is one definition. The another definition is the Casagrande definition, in which if we made a paste of a soil in a standard Casagrande liquid limit device apparatus and make a cut of a standard grooving tool, it will come to close, that groove makes that groove comes closer by the action of number of blows, which is 25 numbers. That is, at 25 number of blows, those two parts of the soil meets. At that point, the water content is known as liquid limit. So it is not possible that you can add the water content of that magnitude or that amount that it will just meet at 25 number of blows. So for that we perform the liquid limit test, which you have already performed in the laboratory, in which a Casagrande apparatus and with the help of the soil given, you perform the test, in which you take out the soil sample and you took the number of blows for different moisture content. So in this test, the number of blows which is less than 15 are not considered, because of below 15 the soil cannot be recorded right number of blows, because the moisture content is very much low. Similarly, if the moisture content is very high, the number of blows may be increased from 35 number cannot be taken into consideration. So number of blows between 15 to 35 are ideally taken into consideration for this test, liquid limit test, in which you recorded number of blows and water content, in which you plotted this log or simple log and simple scale, that is semi-log graph, between the water content and number of blows. The number of blows are recorded in the log scale, and the arithmetic scale we plotted the water content. So these are the 4 values which are values on both sides of the 25 number, because we have to calculate, we have to find out the value of the 25 number of blows. So we made this curve with these 4 points. We made this flow curve, and from this flow curve, we at 25 number of blow, we recorded this water content, which is the liquid limit. So this is the way we find out the liquid limit, and how this semi-log graph is plotted same as you have already plotted in the sieve analysis, because this is the 10 to 100 part is taken into consideration, because number of blows are between 15 to 35. Now the plastic limit is the limit in which if we made a thread of a soil sample at a certain thickness, which is 2.5 millimeter, the soil just starts crumble at 3 millimeter, not 2.5, at 3 millimeter, the moisture content at which the soil just starts crumbling, that moisture content is known as the plastic limit. Similarly, the shrinkage limit is performed by making a soil pad, in which you have to calculate the water content at this shrinkage, this semi-solid and solid state transition line. So this is you can go through the lab. There are various indexes using these limits. These are namely plasticity index, which is nothing but the plastic limit minus liquid limit minus plastic limit. That is, this is the range of the plastic state. This is the IP, means range of the plastic state is known as plasticity index. It is very important plastic property of the soil or the fine grained soil. Consistency index is the WL minus W upon 1 IP. IP is the plasticity index, WL liquid limit, and W is the water content or natural water content. Liquidity index is the again natural water content minus plastic limit divided by IP, plasticity index. Shrinkage index is the difference between the plastic limit and the shrinkage limit. Flow index is the important parameter, which is nothing but the slope of this flow curve. Taking slope means tangent theta of this flow curve is the flow index. Means if you can take the two readings in this y-axis and corresponding readings of on the x-axis, you can have the ratio of these two readings, that is tangent theta. This upon this is known as the flow index. Toughness index is the IP upon IF, and similarly activity number is the IP upon percent finer clay, means how much percent of soil is finer than the clay size particle, that is 0.002 millimeters. So these are the indexes and limits by which we can classify the soil, or we can easily find out the various properties of the soil. You have the plasticity chart, which I have already given in the notes. You can go through this plasticity chart, in which this, using these values of liquid limit and plasticity index, etc., you can classify the soil accordingly, whether it is clay soil or silty soil or mixed soil, and type of the plastic properties. So the fine grained soil are classified according to their consistency, that is the ease by which you can mold the soil into different shape. Hope you can understand the Atterberg's limit and their related terms. Thank you very much.